Hello my fellow math enjoyers and welcome to my video where I will be discussing about exact and ordinary interest in business math. I'm your host, Xander Abrea from Gr.11 Y1-19, your guide in today's lesson. Well then, without any more yapping, let's get on to our lesson. Let's go!
Okay, so like I've said, our topic is all about exact and ordinary interest in business math in the subject General Mathematics. Now, our learning targets are identify and differentiate exact and ordinary interest, learn to solve for exact interest, and learn to solve for ordinary interest. So, let us begin with exact interest. Exact interest is a process of calculating for the interest on a debt based on a 365-day year. It doesn't get any simpler than that.
So to understand this much further, we must be familiar with every month. Which month contains 30 days and which month contains 31 days. To identify them much quicker, we have this method called the knuckle method.
The knuckle method is used to identify months with 30 and 31 days quicker. Your knuckles represent months with 31 days, while the gaps are months with 30 days.
So if we try this method, it will be like this. We put our knuckles up, and this is how we identify the months, like this. January, February, March, April, May, June, July, August, September, October, November, and December. Do note that July and August share one knuckle, the pinky knuckle. But not only that, we must be familiar with leap years.
Leap years are when our shortest month, February, gets an extra day added to it. Leap years contains 366 days instead of the usual 365 day. So this is the formula in identifying a leap year. You just take the year and divide it by 4. If you get an answer that is a whole number, it's a leap year. And if you get an answer with a decimal, then it's a normal year.
Alright, here are some examples. So, like I've said before, we just divide the year with 4. So, here we have 1997 and we divide it by 4. As we can see, our answer contains a decimal point. So that means 1997 is a normal year. There we go. And here our next example, the year 2000, we just divided by 4 and as we can see, our answer is a whole number. So that means the year 2000 is a leap year. Next, our third example, the year 1846, we divided by 4, and as we can see, we get an answer with a decimal point. So that means the year 1846 is a normal year. So that is how we identify a year if it's a leap year or not.
Okay, now let's proceed in identifying the numbers of days in a problem. So, to do that, we have actual time and approximate time. So let's proceed first with actual time. Actual time is the actual numbers of days in a calendar, while approximate time are all months having 30 days. So basically, approximate time has a constant value, which is 30. So with that said, let's have an example, shall we?
Okay, here is our next example. November 11, 2007 to January 6, 2009. So let's do the actual time first. We take the number of days in this month, November, by looking at our knuckles. Let's go over here. January, February, March, April, May, June, July, August, September, October, November. We can say that November has 30 days. And then we subtract 11 to 30, and that will be 19. Then list all the months between November 11, 2007 to January 6, 2009. But wait, as we can see, these 2 years are not the same. this is 2007 and this is 2009. There's a whole year between them. We just write down the year that's between them. 2008. We can just simply write the year itself because it's way too long to write all the months between a whole year. That's 12 months that we have to write down. That'll take a lot of time. And then we continue. So that'll be January. Then we just write down the 6 over here. And then we write the number of days in December. So that's 31. And then we identify if the year 2008 is a leap year or not. So we go on our calculators again and we divide the year by 4. As we can see, it's a whole number. By that answer, we can say that the year 2008 is a leap year. So we write down here 366 days. And after that, we just simply add all those again. So that'll be 19 plus 31 plus 366 plus 6. And then that is our final answer. Now let's proceed with approximate. So in approximate, we don't have to identify if that month contains 31 or 30 days. We just have to write the 30, then take the day 11, then subtract it again. That'll be 19. Write down all the months between November to January. Then we write down 6 over here again. And then we write down December as 30 days because remember, we're doing approximate. And approximate has all months into 30 days. Then 2008, we just simply write down 306 because 30 times 12 is 360. Then after that, we simply just add all those again, then we'll get our approximate time. And this is our answer. Final answer is 415 days.
Now let's proceed with the formula for exact interest. So the formula for exact interest is I is equal to P times R times the number of days divided by 365. The I stands for interest, while the R stands for rate, and the P stands for principal value. Now, let's try and solving stuff with this new formula, shall we?
So Kuna borrowed 18,000 pesos with an annual interest of 16% on January 16, 1951 and was due to August 3, 1953. Find the exact interest using both actual and approximate time. So basing on the problem, we can identify that our principal value is equal to 18,000 and our annual rate is 16%, which can be converted into decimal as 16%. To convert percentage to decimal point, we just simply take the number, so that will be 16, and divide it by 100, like so. See, 0.16. So here, I'll do the actual time first. So again, what we did before, we just simply take the number of days, then subtract it by 16, then that will be 15, then January, then list all the days between January 1951 to August 1953. After we list all them, we write 3 again here, then identify if 1952 is a leap year. So as you can see, it's a leap year, so we write 366. Since 1952 is a leap year, we can consider that these 2 years, 1951 and 1953, as normal years because a leap year only occurs every 4 years. 30, then 31 again. Then add all those together. This is our time, or our number of days rather. 90 days. Then we can erase all of this and actually start solving. Go over here. Interest 18,000 multiplied by 0.16. Our number of days and then finally 365. So first we solve these two, so that'll be that, and then we divide these two, so that'll be over here, that number, I cannot read that, and then we multiply these two numbers, and then we'll get our final answer. So our exact interest with actual time is 7,344. Let's proceed with approximate time. 30, since all days in approximate time are all 30 days, then we take 16 over here. That'll be 14 January. Then once again list all the dates. So after that, after we list all of these months between 1951 to 1953, on August we just write 30 in everything since it's approximate time. So I'll start right now. Finally 3. Then to make it simpler, we just count every 30, and then after that we multiply the number of 30s here with 30 itself. So let's go over here, let's count them. 1 2 3 4 17 18. So there's 18 30s here, so we'll multiply it by 18. That, then we take 360 over here, we add it over here. Okay, after that we take 14 and 3 here, then we add it again here. That is our final answer. Okay, let's go over here. Once again, same steps. Our principal value multiplied by our annual rate, multiplied again by our numbers of days, 917, divided by 365. Multiply these two, that will be 280. It's already here. Then we divide these two, that number. Then we multiply 2,880 by 2.51. That's our final answer. Our exact interest in approximate time will be 7,228.8.
So now, let's proceed with ordinary interest. So ordinary interest is the process of calculating the interest on a debt based on a 360 day in a year. So here's the formula for ordinary interest. It is relatively the same as exact interest. The only thing that changed is instead of 365, we have to divide for the number of days. It is now 360 only.
You invested 50,000 pesos with the annual interest rate of 10.6% on October 5, 2005 and matures on February 23, 2006. Find the ordinary interest using both actual and approximate time. So, basing on the problem, principal value is 50,000 and our annual rate is 10.6%, which can be converted to a 0.106. Then our time is, let me just look here, October 5 on 2005, and it matures on, hold on, February 23, oops, 2006. Okay, let's start solving. Our actual time, just since October, that'll be 31 minus 5, that'll be 26. Then list all the months between these two, February, get the number here. Then since October is 31 here, we can write 30 on November and 31 here, then 31 here again since January. Then calculate, and that is our answer. Then our approximate time. So let's start solving for our ordinary interest. Our principal value is 50,000, while our annual rate is 0.106, and our number of days is 141. Then add these or multiply them. That is our answer here. Let me just fix it. And then finally divide both of these. 0.39. Then multiply them. So 5,300 multiplied by 0.39. That's our answer. Our ordinary interest with actual time is 2067. Let's go with approximate time. So just list all months as 30 days, then take the 5 from October, that'll be 25 of October. Then list all the months: November, December, January, February. Then take 23. Then list all the months as 30 since it's approximate time. Then just calculate or add them all together, just like so. That is our approximate time. Okay, let's start here. Once again, nothing special, just distribute the givens, then over here, then finally our time, then the year, it's over here. Then I can just copy off of here, and then we divide those rather. Oh, 0.38. Then multiply them. And that is our ordinary interest with approximate time. Ordinary interest with approximate time, that is Thank you all so very much for watching my video about exact and ordinary interest in business math. As Dr. Seuss once said, sometimes the questions are complicated, but the answers are simple. I hope you all learned today. Bye-bye!